Welcome back, everybody. I hope you have enjoyed the video, and I hope you also get a chance to fill in your mug. And we are ramping up here with a second set of panel, and we will discuss more, as I mentioned, technologies. As we indicated in the early discussions, the climate neutrality by 2050 is achievable, and this could be done through electrification of transport, heating, and industry sectors by applying new and existing technologies. And we also need to invest in the grid capacity and technologies to make sure we are able to transmit that sustainable power to the consumers. But then the grid investments have to double themselves from a 40 billion figure today in the next years. We also need to strengthen our interconnector capacity at a level of 85 gigawatts on top of the existing 50 gigawatts today. And we need to have a better and more optimized and integrated offshore grid to basically capture that 450 gigawatt of capacity of offshore wind that we have around Europe. So wind will be at the core of this energy and at the core of this neutrality in 2050 by providing lots of cheap but reliable wind energy, right? And in the next decades, right, we need to maximize its value to the European citizens and consumers and industry, right? So I'm here together with a set of experts to discuss how certain mega trends that our report revealed in the work that we have done, and we have published it now in the report, basically that. As I mentioned already, scaling up offshore wind, it is a critical aspect for us to really get that. Larger turbines, 50 plus megawatts, and these have to be connected to multiple countries. We also need to industrialize floating offshore wind, and the floating part will unlock an additional 60% of Europe's offshore capacity and offshore resources that we can utilize to get the energy from. When we move onshore, we need a happy coexistence of the environment and the society and the turbines themselves. So integration of wind turbines into the surrounding environment is becoming crucial, and we need to make sure that we have the full support of the public for that. At the same time, we have been developing and deploying turbines for quite some decades here in Europe, and their lifetime it's coming to an end. We need to look at repowering schemes and how can we make use of those good wind spots and utilize newer, better, larger capacity turbines such that we can make the most out of it. And quite a lot we have discussed in the previous session about wind being 100% circular, right? And we need to look at new materials that at the recycling technology, but also how do we make sure we are using less and less materials into our products. So today I'm joined by some experts to discuss all of this, and as I mentioned earlier, we have Henrik Stiesdal, the CEO and founder of Stiesdal's IS. We have Daniel Merfet, the CTO of GE Renewable Energy, Paul Skjærbeck, the Chief Innovation Officer at Siemens Gamesa, and then we have Jen Iori, PhD student at DTU, the Wind Energy Department. Welcome all to this discussion. I'm so happy to have you here.
Thanks.
Maybe Rick, you are a true pioneer of wind power, and let me start with a question to you, as we have repeated throughout the day. We need upscaling of wind turbines. Is bigger really better? And how do we make sure that these big turbines will have more or limited environmental impact?
Yeah, that's of course a good question, because we have always been wrong in our predictions about turbine sizes. Certainly I have been for decades, always underestimating the beneficial impact of going larger. For many years we thought that smaller, there was a certain maximum, and then we thought it was at a higher level and so on. And gradually we've come to realize that we were always wrong. And the trick is, of course, that while the theory stipulates through the so-called square cube law that the weight per wind capture area should go up in an undesirable way, the benefits of limiting the number of units to be installed simply outweigh this negative impact of the square cube law. And also the fact is that we actually don't see the square cube law being really cubed versus square. It is a lower power ratio. And there we must say that until now, it has proven to be so that bigger was always better. The growth is really very simple. We have a doubling time of 10 years in offshore wind on our turbine size. And the 2025 turbine will be a 15 megawatt. The 2030 turbine will be a 20 megawatt. The 2050 turbine, if we extrapolate, will be an 85 megawatt with 550 meter rotor diameter. Do I believe that? Not really. So somewhere there's a ceiling. We just have to note that we have not yet been able to predict it properly. Regarding the materials, there's no big difference on the material use. On the big turbines, they essentially use the same types of materials. Some of the active materials reduce a bit relative to the structural materials like steel. When it comes to the environmental impact on, for example, the seabed, bigger is better because bigger is fewer interactions with the seabed, and that is as a baseline always better. So yes, bigger is better. There's a limit somewhere out there. We don't know yet where that is.
Thank you very much. Daniel, let's move over to you. I mean, behind these wind turbines, bigger and bigger wind turbines, right, there is a lot of key innovations to be made. What are the challenges on the technology side, but also for you personally as the CTO of GE Renewable Energy?
So the innovation and the challenges go hand in hand, because when we were developing our 14 megawatt Haliade X, some of the things that we had to invent or develop for it were the things that took us the most time. I mean, certainly our blade construction had to be different. We are using a novel carbon construction just to get the right stiffness and weight. And although the blade length can increase, and generally blades haven't changed in their construction dramatically over some period of time, in terms of materials, there's going to have to be continued innovation there just to be able to continue along, to march the path that Henrik just described. The other piece, maybe even more holistic, is the system optimization that is required when we're thinking about such large systems. And this includes not just the turbine system, but the vessels and the offshore construction. You know, we want to minimize offshore operations as much as possible in all the phases: installation, commissioning, O&M, and digital and robotics will play a part, but also system design. We looked into operability and decided that we really needed to embed all the electrical equipment into the nacelle and the hub assembly, for example, just allowing as much testing of the equipment in manufacturing and just reducing those commissioning cycles. So the bigger the systems are, the more we want to take advantage of having fewer of them for a certain size offshore wind farm, visiting them less, creating as much autonomous behavior as possible. That's probably been the biggest innovation and challenge, managing that risk across the whole system development.
Thank you, Michelle. We discussed earlier, and I mentioned also in my speech at the beginning, about being 100, or the ambition of being 100% circular there. Paul, from an innovation perspective, do we have already the recycled technologies that we need? Do we have all the sustainable materials? Do we know them? Do we know how to apply them? What are our opportunities, but also maybe some challenges to really make wind 100% circular?
I think in general, we have most of you say, the technologies needed, and we also see a lot of emerging things coming up. But I think also circularity is also about, I think Henrik also how we use material in an effective way, and we use the product as long as possible. And I think if you look historically, we have beaten the square cube law. We have actually managed to make the bigger machines without they kind of scaled in the consumption of material in the same way. So I think in that sense, we have actually made a lot of progress in the last 20 years. if we have just scaled the turbine design 20 years ago to today, that would have been monsters. So in that sense, we have done a lot. Of course, we have the blades, which is a key challenge still, because at least the ones we have out there it's not solved what we do with them and how we actually bring them back to new turbines. But I would say in general, I actually think we have most of the technologies. The rest of the turbines is pretty straightforward to reuse. But I think it's important that we also get the assets we have out there really used. And if you look at many of the turbines installed today, they are designed for 20 years. Maybe the lease for the wind farm is for 20 years. Many of them can most likely run for both 30 and maybe even 40 years. And I think we also need to make sure we harvest these kind of things before we actually start reusing the materials. So there are many aspects in this, seems much, yeah. But for a very large fraction, I think we are good to go to kind of reusing the materials.
Excellent, thank you, Paul. Jenna, now a lot of R&D lately is focused on offshore wind, and if you have participated in the previous discussion, it was kind of dominated by offshore as one of the topics there. But onshore wind will also be as much the backbone of the future energy system here in Europe. How can we improve the onshore technology? What are your findings in your research? Any new concepts or innovative concepts that you foresee there?
Well, I would say that one of the major challenges, in my opinion, in onshore is the societal aspect of it, because offshore, when you have onshore wind turbine, you're interacting a lot with society, much more than when it's offshore. So I think this is where it's a good idea to have a systems engineering approach in how you design your wind turbines and your wind farm, which means consider not only the wind turbine itself, but how it interacts with, let's say, operation and maintenance, construction, society, how it interacts with the neighbors. And one thing that part of the research that is very interesting on this aspect is to, instead of designing the wind farm and the wind turbine in terms of decreasing the LCOE, considering how it can add value to society. And I think that's a very exciting research area, especially when we think about the fact that in 30 years, there would be wind turbines basically everywhere.
All right, thank you very much indeed. Having them around us and us agreeing to see them around, right, will be a very good, let's say, step forward for us, admitting that investing in clean and wind power will need to, coexist between humans and such machines around them. If we look a bit at the, technology part, and maybe I come back to you, Paul, on this, and maybe Danielle, you also commented on your initial intervention, right? It is getting outside of the turbine, looking at the systems, but we also now get into the wider transformation of the energy system there, right? And we are the technology that we are developing in the turbines, they are immediately relating with the technologies that are for the grid connections to the consumers, right? But then we are also now discussing about having power tweaks and having additional, let's call it green molecules, right? Additional energy carriers that can be out there. How do you see this from a technology development, right? What is the right, wind turbine technology, first of all, and the transmission technologies linked together? What kind of opportunities we have there, right? And can we benefit of this HVDC technologies? And can we benefit of the electrolyzer and the hydrogen as being another energy carrier there? Maybe Paul, you go first, and then Danielle, if you have something to add.
Yeah, I can definitely start. And I think first of all, if you look at the big picture, I think the reality is today we have kind of generated today around 2% of the world's energy consumption from renewables. So the challenge we have ahead of us is enormous. And I think we need really to think hard how we optimize the system. And I think power takes and electrolyzers provide an opportunity both to balance the grid, to make sure we we use the grid for transporting electricity to wherever the electricity is needed, and then take the excess power away and turn it into a different form. So there's definitely an opportunity to couple it, these two sectors of generating something else than electricity. That being said, I also think we need to realize that if we really want to go to a full decarbonization, reality is that the build out of the grids will need to be so massive if we want to replace all the natural gas pipes going into Central Europe, etc., and bring everything in as electrons. The build out of the grids will be massive. And I think there'll be countries where it's simply not possible. So I think we need to think in a parallel system where we also get energy transported over long distances in molecules instead of, if the end need is molecules, we should preferably convert it as fast as possible, because the asset you need to build are cheaper and much more effective. But obviously we'll see a mix at the end of the day, because there will be smaller consumers where you would take electricity from the grid and turn it into hydrogen or whatever. But for the massive amounts you would need for big industries, I think that will be difficult. And I also think there's another element where we, with turning the electricity into molecules fast, we can also start to utilize wind farms at locations where there are no grids available. I think we can go to really high wind sites far away and build a much cheaper transmission asset if we go to molecules, provided that we need the molecules and not the electrons. So there are huge opportunities in optimizing this system.
Thanks.
Yeah, the only thing I would add to that, because I think that's very well said, is as Paul mentioned, that HVDC and electrolyzers are both great examples of DC DC systems. So ultimately, the power electronics components of our systems designs can be modified. And I don't know that it really takes out a lot of cost from a system. I think there's always improvements and there's always optimizations to be had, but ultimately not converting to AC and then back to DC for various uses. You just design a system more holistically. As we start to see these various use cases, driving, say, hydrogen upstream value, you're likely going to see very tailored system designs, and the power electronics are so easily, they're the connective glue between a lot of these systems. So I can see us modifying them extremely as we move forward in this energy system landscape.
All right, thank you. And I saw you, Henrik, nodding a lot when both Daniel and Paul were talking. Anything to add from your side, Henrik?
Just a few sort of supplementary comments. In our view, transporting hydrogen is per energy about 1/10 of the cost of transporting electricity. And that, of course, substantiates Paul's argument very much. When it comes to getting into other sectors, here in Denmark, the 2030 prediction is that out of our total CO2 footprint from Danish society, 5% only will come from energy. 9% will come from waste, and the rest will come from farming, transportation, and industry. And a lot of those elements cannot be electrified directly. The only way we can get into that, the vector that's always there, the only vector we have is through hydrogen. Everything else starts with hydrogen. So that's just to emphasize this note that hydrogen is our way into the sectors that cannot easily be electrified. And they include, for instance, high temperature industrial processes, steel making, ocean-going ships, and so on. They cannot be electrified. That they need our molecules, as Paul says. So it's really a super important supplementary factor in the build out of renewables.
Excellent. Jenna, anything from your studies that will?
Oh, I think mostly everything, like all the points from the other people in the discussion have been very relevant. I think what Paul said about having access to places with high wind, but no grid access necessarily is extremely interesting, because being able to have this power to X technology allow us to be more flexible, let's say, in how we collect energy from the wind.
Good. Let's shift a bit gears and move more from, we stay connected to the technology, but we know behind technology are brains, and behind the brains are people, right? So people and then brains. how easy, right, is to, first of all, find talent in the sector, and how important is the education of this talent to allow us to, grow with the pace that we want to grow. Maybe Danielle, we start from you.
Yeah, I mean, I would say all advanced technology sectors pull on some of the same core technical skills and education levels. One thing I've found in the wind sector is that a common need across a lot of our development space, even in the area of the molecules application rather than just the power sector, is controls. And control systems obviously also span quite a bit of application space in our sector. But there's so many other industries that are also growing, whether it's electric vehicles or the gaming industry or cybersecurity, that have very similar educational requirements for their skills. So it's not just wind growing so fast and needing to supplement our workforce with more trained and skilled people that can develop domain experience. It's now also competing with these other very fast growing, transforming sectors around us. So as many educated engineers, technologists, innovators that we can pull into the wind sector, we're going to be better off, because the growth here will require us to be collaborative, innovative, and also using some of those other technologies and supplying electricity for things like electric vehicles, but we're competing with those same companies for talent. So it's a race for talent at this point.
Yeah. And I think, Jenna, you are one of those, entering the sector. I'm not sure whether all your studies were there, but definitely your PhD is looking at wind turbine optimization here. Why did you select this field? What attracted you to be here? And have you, when you selected, or when you, being approved in the program, were there a lot of programs to select from, or, you had only a few limited opportunities or possibilities?
Well, I think since the start of my studies, I've always been very interested by sustainability in general, and I wanted to have a positive impact on the world, let's say. And I think the best way to do this is to allocate dedicate your career for this. And at the time when I had to choose a bit my specialization, I thought that, wind turbines are pretty simple. It's just mechanical, just things that turn, produce energy. And so this is why I chose to go in this field. Now, with 4 years of experience, I realized that it's not a simple system at all. I think when I chose my education, I was mainly looking at Europe. And one thing that is striking is that it's not very often that you can have specialized education in wind energy. And I think it's actually very important, because since wind turbines are very complex systems, it's important to, let's say, understand control theory, as Daniel mentioned, but also understand how the control theory can interact with all the other parts of the wind turbine, and understand, let's say, control theory in the context of this mega structure that turns for 20 years. Yes.
All right. Thank you very much. And maybe then I challenge all the others in the panel here to see how much are you, recognize yourself right now in Jenna as being, a new student there. Obviously, in my time, and probably even earlier than that, it was slightly more difficult. Any other opinions?
No, if I go maybe back to the more fundamental part of the question, I think that in wind, we benefit greatly from this self-motivating factor that people working in wind power do good stuff. I think that's super important, as also Jenna mentioned, that to work in sustainability, that's only getting stronger and stronger. And there we are very much benefited from that. Having said that, of course, there are areas where the talent pool that is sort of adjacent to you might not be sufficient. And we had that in Siemens Wind Power. What is that now, 12, 13, 14 years ago, where we found that we could not get all the aerodynamic expertise that we needed in Denmark. And therefore, we built up a competence center in Boulder, Colorado, in the US, where the talent pool on aerodynamics was much larger. And there, of course, the big multinationals like GE and Siemens Gamesa, Vestas, they do benefit from having access to a a worldwide talent pool. And there I think that when you have that access, I really think that our sustainability, what should we say, attraction is going to drive a lot in securing the right talents for our industry.
I'll just add also that in the last year, we've noticed, obviously, and we've seen in action, the ability to get work done from a lot of different locations. So we're able to now consider that we can access talent that doesn't necessarily live where, you know, our work is being done, or next to the, you know, engineering center hub, or near the prototype site. So, you know, having people who are focused and have that passion, as you were mentioning, is just is a powerful thing. So to harness that and attack those problems with the right talent in the right places, it's not as limited as it was in the past, for sure.
Paul, anything from your side?
No, I can only agree to what's been said here, and I see that what Henrik mentioned all the time, this desire that people really want to work in a real green company. I think that's where we have a unique position in wind, especially because it just attracts a lot of people. And I think with access to the global pool of talent, I think actually we can find the people needed. But we are in competition with that. We see a lot of hype around the electrolyzer business, and they are also getting very interesting for many of the new talents. That's for sure.
Yeah. Yes. I think I concur with all of you that the sustainability message that many of the companies around the energy sector are providing now and advertising out there should be one of the mechanisms basically to get more talent being interested in doing good for the world, right? For the world of tomorrow. But we also have a very active audience, even though maybe some of us may not see it. So I have a bunch of questions here, and some are very targeted to some of you, some are more general for the entire panel. So let me go to them and maybe start with you, Paul, and back to the topic of the sustainability, circularity, 100% sustainable circular turbines. On the raw material, steel, rare earths, and so forth, what is the state of current research? Can we source all of this, all of the necessary quantities that we need in the short term, and what's the plan for the long term?
I would say with the current volume we see right now, I think we can source the materials needed. We see steel and other materials going quite a lot up in price recently. But of course, we need to work both in the companies and with research institutes to minimize and optimize the use of anything from magnets to copper to whatever. So I think there is still a huge task really to make sure we get the maximum out of the materials we use. But I fundamentally do not see there is an urgent shortage of materials. But clearly, if I mean, at the moment we are installing hundreds of offshore turbines here. If that turns into thousands in order to do the transition, then it may get we start to be a dominant consumer in a lot of the materials we're talking about here. So I think we need to stay sharp and make sure we really optimize our use of materials, and we need to make sure there are proper programs in place, and we are also doing that in Siemens Gamesa. But I think on a broader scale, we really need to make sure we focus on optimizing the use of materials.
Very good. Let's stay on this topic of supply chain here, and there is one for you, Danielle. And to what extent do you actually consider the existing supply chain in your design? Maybe co-creation, collaboration with the suppliers, and so on.
So I think it's very important for us to understand the stability of the supply chain. And as we're making changes, we can't innovate in every facet, every area at once, because it just would be too much compounded risk of developing all those new materials, techniques, designs, and supply chain. So typically when we are innovating our next big step forward, we've got one or two key components or subsystems that might have a big enough change that would require us to develop something new in the supply chain, either an innovation we develop or partnerships that we create. But absolutely, we have to consider that, because any great innovation that doesn't have the supply chain support to scale isn't a great innovation, because you can't scale it and it won't reach market maturity in the near term, which is what we all look for.
All right. And let's stay in the area of turbines, right? And Jen, I come back to you now. because one of your area of focus is to find the best turbine designed for the future, right? In your view, what does a turbine look like in 15 to 20 years from now?
Well, honestly, I think the look of it will probably not change so much, or at least I find wind turbine beautiful, so maybe it's a bias that I have. But I think it's more in how it's made. So I think there would probably be a shift in the material that we use to push for more sustainable material and materials that are easier to recycle. But also, I think there would be more influence of active control. So I know that there is very active research on flaps, active flaps that you can put on your blade, and this can really open a door for better performances of the wind turbine and better adaptability to the wind resource.
All right, thanks. Then if we are there at the blades and so on, Danielle, for you a question here on modular blades. Is this the future for onshore wind?
I think as we continue to see the rotor diameter increase, it will become increasingly the future for onshore wind, yes. Only because the logistics will constrain that growth otherwise. And I think modular construction, modular installation, even modular development of other parts of the turbine system will be opportunities for reducing cost, increasing quality, reducing logistics challenges that we find even in towers. So blades are the first big foray into modular construction, and I think it will only grow.
Excellent, good. Now let's move a bit offshore, right? And then we've discussed a lot previously about the floating offshore there, and there is a range of different floaters design in the market, and particularly in the research at the moment. Henrik, do you see a situation where we will have multiple models become commercially available, and are they viable, or do we see a consolidation of the markets and we have maybe 2-3 models that all manufacturers will use and developers will use?
Yes, most likely. Of course, we see it also in the turbines that 40 years ago, we had all kinds of variants, vertical axis, horizontal axis, 2, 3, 4 blades, etc., upwind, downwind, and so on. And a standard solution has emerged that we all know, the 3-bladed upwind, etc. We had in aircraft and in many other things, there's a similar development where ultimately nowadays you can't distinguish unless you are an aficionado whether an aircraft at a certain distance is a Boeing or an Airbus, because they look like aircraft do. And the same will apply here. We have had many different concepts for bottom fixed foundations, and ultimately one version, the monopile, has emerged as the clear volume winner. We still have jackets, we still have tripods, we still have concrete gravity bases, but the overall winner, so to speak, has been one. That's the monopile. And I think the same will apply to floating.
Excellent. Look, there are a lot of questions coming in and about hydrogen and renewables and how we can produce hydrogen renewables, how and when we use that. I think I would propose we'll set that aside for the time being, and maybe we will organize a specific event about it later on. I have an interesting question here, which I would like you all to think about and maybe answer parts of it, and goes back to the skills area. And we discussed the skills about specifics of the wind technology, right, and wind turbines and wind applications, so on. But digitalization, it's also one technology and one hope also for the wind industry to cut costs of the energy, right, get better at operating, at maintaining the infrastructure that we will build, the thousands, the tens of thousands, and possibly hundreds of thousands of turbines that will be out there. They will need to be monitored, they will need to be taken care of. When it comes to skills, obviously, there are skills of digitalization. There are other sectors which are more attractive for our talent here. How do you cope this in your respective companies? And, how do you get access to talent that is capable of solving complex problems also for the wind energy? Maybe Paul, we start from your side first.
Yeah, I think it's a very good question, and it is a real challenge, and I think the industry has been a little maybe not being finding the right path when it comes to digitalization initially, because digitalization is many things. Where I see at least a big move is on the whole, you could say, we see the drones taking over inspection of blades, etc. There are actually quite a lot happening where we remove manual labor with more autonomous systems. So I think we are getting there as an industry, but I still think we need to look ahead to a fully decarbonized world where we have hundreds of thousands of wind turbines. I think we will need completely different ways of operating our assets, of installing them, etc., because we will not just scale up the business we have today. There will simply not be enough people for that. So I don't have the perfect answer for it, but I think at least we need to think in how do we really use digitalization to scale this business, because it will not be one-to-one with people.
Yeah, I'll just add, I think this could be a great area for us to go on the offensive as an industry and go out to those other industries that are generating talent or techniques in things like GPUs and the use of advanced artificial intelligence or machine learning to operate our systems. And we should use the purpose of the energy transition and the future of the planet as a way to pull them in and bring that talent into our sector.
Gina, I guess you in your work or the field of work, you would anyhow need to use already the computer programs, a lot of things that are, requiring quite some analytic skills, right? Kind of high power computing, kinds of, new ways of analyzing data, looking at the data, testing data, be more effective, be faster, and so on. Any experience here and with the audience?
Sorry, can you repeat the last part?
Yeah, any experience that you have with utilizing this in your studies that you can share with us and the audience?
Well, I would say that manipulating data and using like high performance computers is part of engineering, or at least for wind energy at the moment, especially because you want to do simulation that are very high fidelity, these kind of things. And of course, there's not so much knowledge that a single person can have. So, for example, at ETIPWind Event, there are people who are specialized in this kind of domains that we can collaborate with, so that they help everyone, let's say, to get more familiar with this method, like this whole digitalization system. I think increasingly you have more education in this area, and as Daniel and Paul said, you need to attract these people into wind energy.
Yeah, and I think we should be very honored that we have with us in the panel here someone that has a lot of knowledge in wind industry. And that Henrik, you've been considered a guru of wind energy from early days of it. I would not like to close this panel without asking this. Have we done our homework well? Are we looking at the right trends ahead? Are we missing something from a technology perspective to grow the wind industry in the right direction?
Yeah, that's of course a super good question. And I feel a little bad about being the backseat driver relative to the ETIP report, because there's nothing easier than kind of coming after the fact and commenting. But there are two things I think that are underemphasized in the report that is actually being disclosed today. Industrialization is mentioned, as far as I could count, once. And that's just for floating offshore foundations. Industrialization is going to be absolutely key to everything that we do, because the task ahead of us is so immense. If we take the IEA net zero report that was out a few weeks back, and is really going to be a cornerstone in many countries' energy policy making over the coming years, because it's such a strong, forceful, well thought out document. They set out growth paths for us. On offshore wind, the growth path is to take us from 5 gigawatts of installation last year to 80 gigawatts per year in 10 years from now. So that's not just like, yeah, we need to grow double in size or something. We need to grow by a factor of 16. And the only way we can do that is to take a radically more ambitious look at industrialization through our sector. The other thing I'm missing somewhat in the report is a comment on the supply chain challenge this amounts to, because that is actually going to be very big. How are we going to have the whole chain that will deliver these 16 times higher rating than what we delivered last year to get that up and running? And of course, we have the benefit of innovation, and the benefit of innovation is huge. There's actually a few weeks back we installed the first turbine on a floating foundation that I was involved in, and that's a Siemens 3.6 megawatt turbine. If we had taken the bonus later Siemens turbine of 40 years ago, 1981, and had scaled that up according to the square cube law, the nacelle of that turbine would have weighed about 2,000 tons. And the nacelle that I put up weighs 100 tons. That shows the power of innovation over those 40 years. And that's, of course, a completely inherent part of us going forward. That is that we need to have that continued pressure on our design that Jenna and others are doing with making smarter and smarter turbines. But we still have those two things. And I think they are kind of under-emphasized in the report. Industrialization, getting the supply chain going. Other than that, it's a brilliant piece of work that has been delivered by ET.
Thank you very much, Henrik, and thank you all. We are running out of time here on this session, but thanks a lot for taking the time and be with us here and explain to the audience what are the key challenges that we have ahead of us in terms of technologies, but also opportunities and how can we get this done. With that, thanks a lot. We will continue with the next session on R&I budgets and the policy for that we need to get for the wind expansion. See you there.
Thank you.
Thank you. Bye-bye.
Thanks.
Bye-bye.
Hello there. Today I'd like to tell you a story. It's a story about people, our planet, and science. Our story starts with a vision in the 1980s. A vision that one day we would be able to power Europe with local, clean, and renewable energy from wind. At that time, wind turbines were not as powerful as they are today, and wind energy was just 0.001% of Europe's electricity. Yet in just a few decades, Europeans made this vision a reality. They created new, more powerful turbines, opened factories, and developed a strong industry. Today, wind provides 16% of Europe's electricity. It employs 300,000 people in Europe and brings many economic benefits to both local communities and society. So how did this happen? With the dedication of thousands of people across Europe and their passion for wind energy. And thanks to the European research and innovation community, scientists, universities, SMEs, research institutes, they have been the engine behind every major technological advancement and every new idea. The European Union recognizes the strategic importance of research and innovation in maintaining our global leadership in wind energy. In 2016, it established ETIPWind, the European technology and innovation platform on wind energy. ETIPWind identifies common research priorities and fosters innovation in the sector.
Over the past 4 years, the work done by the ETIPWind has helped the European research and innovation community to make wind energy better and stronger. It has given researchers, universities and companies from all over Europe the opportunity to share knowledge and shape the future of wind energy.
Thanks to EU funding, we at Monvion are showcasing the next generation of wind turbine towers.
Offshore grids have been a big field of research where Europe has been on the leading edge globally.
Thanks to the European Union's funding, the Ocean project has created a network of highly skilled young professionals in the field of wind farm operation and maintenance.
We need floating wind. The flagship project is the starting point for near-future full commercial project that will come.
La contribución de la Comisión Europea está permitiendo un avance significativo hacia la reducción de costes de operación y mantenimiento offshore.
As a blade designer and manufacturer, We can influence the sustainability of our products during the design process by designing with sustainability in mind.
We've told you a story that we can all be proud of, but the story doesn't end here. We must continue to invest in research and innovation for wind energy.
Wind energy will be key to Europe's decarbonisation by 2050. In the European Commission, we could see wind providing at least half of Europe's electricity by 2050. We're already global leaders in wind energy technology, and the European Union recognises the strategic importance of research and innovation to maintain this position. We believe strongly that it is vital that academia, research organisations and industry work together. That's why we support unreservedly the European Technology and Innovation Platform on Wind Energy, the ETIPWind.
ETIPWind, helping European R&I power our future.